morning, students. Apparently, we have a small class this morning.
Good
Um,
morning.
no worries. Oh, good morning. Good morning.
Good
Uh,
morning.
Small class, but we're going to go over some important things today. So, hopefully, some people start to show up soon. I'm really glad you all were able to make it, those of you that are here. It's really great to have you all. We're going to do a quick recap of some of the things we have been talking about when it comes to climate change. We're going to have a really great discussion. And we're going to talk today really about the periodic table of elements. And I see that you guys already, the two of you already put in your guesses as to things that appear on the periodic table of elements. We're going to talk about why one of them is not an element today. And we're going to talk about the other one that is absolutely an element. And so we'll do that. And hopefully we can just have, a great class and a great discussion. You guys are going to have a quick assignment as well that is due. I do want to make sure that I make the new attendance policy clear. So for everybody, you guys are here, so you guys get attendance for today. You guys are good. But for the people who are watching this back later, please make sure that you submit one of the assignments that is available for this week. Make sure you submit one of those assignments by 7 o'clock tonight in order to get credit for today. If you have not attended the live class, but you're watching the video, you must submit an assignment today by 7 o'clock to get attendance for today. Okay? All right. So just to review and recap really quickly, last week in our discussion about climate change, we talked a little bit about the scientific method. Remember, the scientific method is just an organized way for us to think about how we answer questions, right? So we have to think about what the problem is first. Whatever problem is that you're trying to figure out, you're going to do some research and then formulate a hypothesis, which is an educated guess about what the answer is to your question. And then you're going to design and run an experiment to test your hypothesis. In the process of testing your hypothesis with this experiment, you are going to do some research and collect data, right, on your experiment. And then after you've collected your data, you will try to reach some conclusions as to whether or not your hypothesis was correct or whether or not it was incorrect. And if it was incorrect, it's always a good idea to try it again in another way. Or if it is correct, it's also a very good idea to try it again to make sure it works again. But then after you've decided that your results are correct, you have to share your findings, right, with the scientific community. That's how we learn from one another, is by sharing what we've learned. All right. And so why we wanted to make sure we framed the scientific method in the way that we did is we always want to make sure that whenever we're thinking about any information that we're receiving, scientifically or otherwise, we're always asking about where the source is, where it comes from, and whether we know the knowledge to be true, or if it's just like one person saying this thing. And so when we're thinking about climate change, it's also important to think about that as well. Climate change is not this idea of like the world is becoming warmer invariably, but that our climate is changing and why our climate is changing, right? We're trying to research why and ask the question why the climate is changing, and whether or not it's getting warmer or cooler is going to be a result of the climate changing, okay? So that's what we're going to hopefully continue to discuss. All right, and so let's get into it. Hopefully you guys are in Schoology. Make sure you've logged into Schoology and you're in the Science 3 classroom with me. All right, so you're gonna make sure you're looking for me in Science 3. So you should have my name, okay? And what we're gonna do today, we're gonna go into the week 3 folder and we're gonna look at the discussion. I'll show it on my screen. So I'm gonna share it on my screen as soon as I pull it up. Give me a second. Okay. There it goes. Let's share the screen now. Okay. So here we are in our Science 3 classroom, right? I want to make sure that you are all clicking on week 3 that says today's date, September 25th, 2020. click on week 3, the periodic table. And what we're going to answer is this discussion question here at the top. I always put my work in the order that I kind of want you guys to be looking at it. So we're going to start here with the discussion question. And then we're going to go into some of the other things. Actually, this practice might be last today. I might change the order up. Okay, but what is coal and how does it contribute to climate change? So we have a few discussion questions on here. Okay, and am I recording? I am recording. Okay, so so if you go to your discussions, make sure. Let me see. I think somebody just. I think I know what the message is. So let me go back for a second. Great. You should be in that course now. So for Science 3, go ahead and try to refresh and find it. Okay. So what is coal and how does it contribute to climate change? We're going to answer these questions. So we have, so what is coal and how does it contribute to climate change? So if you can answer that question for me by writing.
Should we not look it up or just think off the top of our
Right,
head?
exactly. Don't look it up. Just whatever comes to your mind. If you don't know, that's fine. Say, I have no idea. But if you think what coal is and how it might contribute to climate change, go ahead and write it in there. And then we're going to discuss these 5 questions together. But don't look it up. I want you to just off the top of your head, what is coming up?
What you mean coal? Coal as in, is it the dark coal?
So you tell me. We will discuss it, and I will answer that question. But
I need to. I can't even.
For right now, without knowing a short answer, you tell me what you think coal is, and then we will discuss it. Yes, Ebony, I did see that you are.
Cool.
For whatever reason, Ebony, you are on both.
Oh, okay, yeah.
And I will clarify it for you next week. It doesn't matter this week. You're here. You're going to get attendance.
So we can answer from the chat box.
Yes, just answer right here in the chat box. Well, not on this chat. Answer it on the discussion page on the post.
Oh, okay. I don't know if I can go down to my own because there is I think I have issue with that. Sometimes when I press the escape, it's not going.
Okay, so if it doesn't work, go ahead and answer in the chat, and I'll just post it for you in here in the discussion. Yeah, so you can answer in the chat if that's fine, if that works better. But think about it. What is coal and how does it contribute to climate change? Let me turn my video off for a second. I want to grab my phone so I can text Miss Cook. Okay. All right. We got some comments coming in already. I love it. All right. Okay. Love to see it. Okay, either charcoal burning and too much smoke in the environment. Okay. All right. Any other thoughts? What is coal? What is coal? That's what we're discussing right now on this discussion question in week 3. What is coal and how does it contribute to climate change? If you have a hard time navigating between both Schoology and Zoom, you can put your comment in Zoom, but I prefer it in Schoology if at all possible. We're going to discuss these 5 questions together, but I want to find out first what you think coal is without any knowledge. I haven't given you anything, but this is just off the top of your head. What is coal? How does it contribute to climate change? Oh, I like this. These are good things. Okay. 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 All right. Good, good. I like this. I like this response. Okay. All right. So is coal that we use to grill with or cook with the same as the coal that is dug out of the ground? Is that the same coal?
I think no.
You don't think
I
so?
think this is like I think it's like they do dig the coals out. It's like petrol or
Okay.
some kind of thing, I guess.
Okay.
Coal. It's a natural resources
It is a natural resource. That's very good.
which they dig. It's like an oil, a black stone kind of thing that they use for oil or something for.
Okay. It's used for oil. Okay.
But I don't know. I don't have the time to.
All right. What about good. Okay, this is a good discussion. Thank you guys for posting. Those of you who posted already, you guys can continue to post throughout class. I'm going to just ask a few questions as well while we're thinking about this. So, what is coal made of? What is it? What is it made of?
I think it's natural.
It's natural. Yeah, it's natural. Right? But is it made of something? Is there like a certain substance?
Uh,
Is it just coal? So coal just happens, right? Is that the idea? And anybody can answer. Coal just happens. It's just coal, right? It's just there.
Like fossil fuels, like when you find it, it's like
Yeah.
been like hundreds of years in order to get that density to be what it
Okay.
is.
All right. Very good. I love that. Okay. Good. All right. So what is this? I don't know if you guys have seen it before, but there's like a debate as to whether or not coal is good or bad. And you know, there are many states in our country, not many, but there's a couple of states in our country that really depended on coal for their economy. Why do we think, or what have you heard about coal that makes it bad? I know that Ebony wrote in the chat or in the discussion that the smoke from burning coal that coal gives off isn't helping us fight climate change. Is there another thing that we know about coal? I just want to figure out what you guys know about coal in general. If you've heard about it, if you've like seen any of these debates about it, if you've read anything.
I remember a little while ago, it
Mhm.
was a bunch of people, a bunch of coal miners down
Yeah.
in the mine, and the mine like fell in on them, and it took us like a week or two to get them. Like
Right.
it's messing with the tectonic plates, everything, like the
Okay.
mountains and stuff, and making sinkholes. Like it's not good for the earth, so it's
Okay.
got like filling its own gaps.
All right.
Okay, wait a minute. Was I supposed to put the answer in the chat, or I posted it on?
You could post. You could post it. I would prefer that you posted it. So this is great. What you've done so far is good. Yeah.
Okay.
I like this. Yeah. So great. I've heard all of that. Yes, as well. And yeah, these. So let's clarify a couple things about coal. So coal is definitely a fossil fuel. You guys were spot on that. We do use sort of like a modified version of coal. Like the charcoal that we have is a little bit different than coal from the earth. So charcoal typically is not made out of the same kind of coal dug up from the earth. It's really modified in general. And most of the time, you can make coal by burning and charring wood, and that's a easier and a cheaper way to produce coal. And so some coal briquettes are actually made from wood and not real coal. And you'll see like sometimes on the packages, they'll make that distinction. But yes, some of the coal actually is just a modified version of that coal from the ground that we can use to grill with. But coal is used to produce much of the electricity in this country, right? So we turn that coal energy into electric energy, and that's how we get electricity, right? And companies like Pepco, for instance, run on primarily coal energy, right? But Pepco has been making this whole change now, and they're like, oh, well, we've partnered with these other companies, and if you want us to try to get your energy from somewhere else, just let us know. And like now they're like, working with other companies to try to get energy from different places, but they have been a company that has been dependent on coal energy for a long time, right? And so coal, one of the things that makes coal dangerous is one of the things that Ebony mentioned in her response, right? So the way that we produce coal, that we get coal, that we have to modify it, gives off a lot of smoke, and that returns a lot of the compound that is in coal into the atmosphere. So coal is actually made of carbon, right? Like much of the fossil fuels that we use in general, it is a hydrocarbon, right? So it is made from carbon in general, right? Just like petroleum is made from a hydrocarbon. It's a combination of carbon and hydrogen. Coal is strictly carbon that has been compressed over a certain number of years and it becomes coal. If we leave that coal alone, right, undisturbed and under more pressure for many more years, that coal can actually turn into graphite. And that graphite, if we leave it that under pressure for more time, that graphite could turn into diamonds, right? So carbon is actually, so diamonds are actually just compressed carbon, right? Over millions of years. And so it takes such a long time to make diamonds, and diamonds are such a hard substance, so that's why it's so valued, right? But it really is just carbon that has been compressed for many, many years. So carbon, right? And the elements in general are what we're going to focus today's conversation on, right? We're going to be talking about the elements in general and what carbon is and why carbon is considered an element. And something like fire is actually not considered an element because it is made up of different things. An element has to be a pure substance, okay? It can't be contaminated with anything in order for it to be considered an element. So we're going to discuss that today. When we discuss the periodic table. Okay, so that's going to be the goal of our conversation today, is to kind of talk about carbon, which is part of the periodic table, and then how carbon contributes to climate change. Okay, carbon has been one of these monsters in general. When we talk about climate change, and people are like, oh, global warming is caused by carbon. And it's like, and you hear that and you think like all carbon is bad. And it's really not, because we use carbon in many different things in many different ways. We value carbon when carbon is worn on our fingers, right? Like people love that bling, right? On our fingers and our ears, on chains and necklaces. So I'm trying to make sure that we don't think that all of these ideas about carbon are bad, and try to just think about how we benefit from the use of carbon and why actually carbon is not a horrible thing and it is a natural thing. All right. So now we have these 5 questions that we're going to discuss together kind of as a class, and we're going to just decide if you agree or disagree with these following statements. All right, so number 1, it says preventing climate change is more important than the economies of towns that rely on fossil fuels. Do you agree or disagree? Preventing climate change is more important than the economies of towns that rely on fossil fuels.
I believe it.
Agree, right? Yeah.
Yeah, you agree? I mean, this isn't a value judgment. There's no right or wrong answer. What do you think? Right, so you guys, if you agree, you agree, right? Okay, so we agree. So is there a reason you agree? Why do you agree?
You definitely don't want the climate gets bad. That's not good for the earth.
Okay, all right, good. All right, so that's a reason to agree. But what about if I say that my town, let's say that Washington, D.C. depended on coal production, right? And I have 5 people in my family who are employed by the coal company. I might feel differently, right? I might think that I don't care about the climate changing, I want my money, right? So how do you balance both of those things?
You have to find an alternative that'll still be as lucrative but not as dangerous to the planet. Like there's lots of ways to do it. I mean,
right.
I think the sun is the number one thing everyone's overlooking. Like,
yeah. Okay, that's great. I love that. And the sun is often overlooked, right? Until recently, we didn't want to do solar panels, right? And then DC made a big movement to get solar panels into the city. And it's been a job that has employed over 45 people in the last 3 years, and it's still growing, right? And so if you get certified, you can become a certified, solar panel installer, which is not like a safe job by any means, right? Like you have to be on people's roofs and things like that. But it is a pretty lucrative job. It's not a job that's going to go away anytime soon. So those are, things like that. Like economies can change their focus as Ebony said, right, if they find something else more lucrative. Okay.
I think they should bring back the windmill, like in places like Chicago, where the
Mhm.
wind is like a thing. They should
Yeah.
bring back windmills.
Yeah.
They
Yeah,
can-
I think, in many places, you really just depend on proximity to a big body of water in order to make a windmill useful, right? Because winds can come as long as there are big bodies of water, not necessarily just in places like Chicago. And Chicago is named the Windy City. People think because of the wind that comes from the city, but actually it's the wind, because it's been a place that has produced a lot of politicians, right? And these politicians have just been blowing a lot of air. So that's how it gets the name the Windy City, not from the weather in the city.
I've been to Chicago. It's pretty windy.
But there are times, because there's a lake there, right? There's a lake, so that lake
I was
produces.
about to say it's cold.
It's
hell.
cold. It's cold there.
Canada
It's
is like
100% cold there.
cold.
I spent 2 New Year's Eves there, and I was like, I'm never coming back here again. I don't know why y'all let me come out here. Okay, very good. All right, but what about number 2? People employed in fossil fuel industries do not care about the environment. You guys agree or disagree? People employed in fossil fuel industries.
I was, I was
They're making
about to
so
say.
much money. Why would they care? They could buy air. Like the movie Gomorrah, they could buy air. They don't care about the little man. If we have air, if they blow down all the trees, they don't care. They got money.
Right.
They probably got oxygen tanks. Like they don't care about us.
They don't care.
I agree.
All right. Again, devil's advocate, right? I got to take the counterpoint. I am employed by the fossil fuel industry. I work in a coal mine. I'm a coal miner. I make $35,000 a year.
They make like 100,000 a year. It's a very dangerous job. that thing went down. I was like, whoa, they can pay a lot.
They get paid a lot, but there's also a season, right, for the coal industry. So what it works out to is actually not a lot a year, because they actually don't have them in the mines at times when they can't be down there, right? So like it gets very dangerous when it gets too cold outside for them to be even further down into the earth, right? So it's a seasonal job. So they make a ton of money during that time period, and then they are out of work the rest of the year. So there's part of it. But yes, I think in general, I agree because of the amount of corporations, right, that are involved in fossil fuel. They care more about the money than they do the environment. Yeah, I think that's pretty true. All right, what about number 3? Our modern world can exist without a reliance on fossil fuels.
It can be done.
It can be done?
They ain't gonna like it. It's gonna get rough the first. It's gonna be a little rough, like everything else when you first start. But it could be done.
Yeah, and I think that's what we're trying to go for, right? Is to have a better climate.
But how do we do that when we rely so much? Like, if people are going to really give up electricity, till they switch over to a better source? Like, we're not going to.
I'm not giving up electricity. I know that for a fact. But
I think it's going to be like going back to the old time.
Okay.
I prefer electric over indoor plumbing. Give me my water indoors. I'll take that I'll leave electricity. If that was the choice, give me indoor plumbing, because I'm not going outside.
But if you've been in a country where you have difficulties of having electric, you won't want to live that kind of way.
Yeah.
It's not easy at all. It's very, very difficult living in a country where there is no. It's like living in sadness, especially when it comes to nighttime, and then if the weather is cold, very cold or hot.
Yeah, I can't imagine. I think that, like it sounds like a good thing and a noble thing, but I have to agree with Jennifer. Like, I think about it and I'm like, I could do it like, in April and May, but November, December, I'd be like, nope, where's my heat?
No,
I need my heat.
It's not possible.
Oh no, I'm gonna build me a chimney in mine. It's gonna be like that. Just leave me alone. I'm gonna be great. I got my walls and my windows. Great, my indoor plumbing. I'm great.
That's big. Okay. All right. All right. What about number 4? It is important to consider the human cost of shifting away from fossil fuels, such as lost jobs and changing economies. Do you agree or disagree?
It is.
Yeah.
All right. Yeah, I think people are going to lose their jobs, but I think if we plan for the lost jobs by creating new jobs first before we make that shift, I think that's how we save people, right? Yes, we all want to get rid of things that are causing our planet to become warmer, our planet to become less safe. But we have to find an alternative first. We can't just say, oh, let's make that shift and then not employ people in that shift, right? I think that's the biggest change. So we have to make sure that we figure out what those new jobs are, start employing those people, training those people more importantly, right? Because a lot of these things will be like, oh, here's this new job. You should know how to do it already. How can I know how to do it when the job just started? I don't understand. Where did that come from? So we have to make sure that we're planning ahead by training people for this. Okay, and finally, our society needs energy from fossil fuels, and transitioning to renewable energy sources won't work. Do we agree or disagree?
We don't know. It might work, but it will take a long time.
Okay.
It might take a long time.
But we gotta figure out different renewable energy sources, right?
Yeah, we definitely do. Yeah, we can't rely on one. We definitely have to think about different ways to do renewable energy. Solar, wind, right? Those are priority things that we can really think about. But here's, especially in this country, here's what's going to make that very difficult, right? I think we already mentioned it. There are corporations who are benefiting from fossil fuels. Those corporations can buy politicians and be like, so I know that your people are saying that they want this in this city or state, but you don't want this. Trust me, you don't want this, and I'm going to buy you a new car to make sure that you don't vote for this. You know what I mean? Like, or whatever. They'll manipulate the system in some kind of way. And so that's why it's hard to make those changes kind of happen societally, because people are people, right? And it's like, it doesn't matter if you're a politician who's been elected on this idea that you're going to do great things. When somebody's like, here's this money, you're going to be like, I do have a family to feed. So let me go ahead and take this money now and then tell my people that I just couldn't make it happen, right? So people are just people, and we have to kind of think about what that really means about how we change from one thing to another. It's going to be a little difficult.
And
All right.
Can I ask a question?
Absolutely.
Okay, like everybody now, we're really talking about climate change. Yes, it might have changed, but during the old time, during those times, we don't have all these experiments, these things and everything.
Mm-hmm.
But there are some, in those days, there are some history that said there was a town so many years ago that disappeared.
Okay.
And then there are different places. That time when the climate when we've not been destroying the climate,
right?
And this kind of thing still happen. So what caused that period of time?
Right. So I think that here's what's happening, right? So our climate has always changed and shifted, right? I think what we're noticing here is a different kind of change happening because of the things that we as people are doing to the earth, right? So it's different when the earth was making changes on its own without too much interference, but because of our industrialized society, because of our dependence on fossil fuels and the way that we overuse things on the earth right now, the change is happening very drastically and very quickly. That's the difference between now and then, right? Okay. So like changes are natural. The earth should be changing, right? Because the earth is supposed to change and adapt as needed, but the earth can't adapt to us because we as people are doing way too much, right? We're doing way too many things and we're not allowing the earth to really change naturally. So I think that's the difference between now and then, right? And so we just have to give the earth a chance to renew itself, to change itself, and to make itself better. But we're not allowing that to happen by all the things that we're doing. Even during this pandemic, there's a website you can go to, like Flight Scanner or whatever. And I'm like, they were like, oh, people aren't flying because of X, Y, and Z, and you can't go to this country or that country because they're not allowing you in. And so in general, you would think that that means that there aren't a lot of flights happening around the world, right? But even during the height of this pandemic, like I remember mid-April, I was like, oh, let me just look at flyscanner.net. And flyscanner.net tracks all the active flights in the world. And so you look at the world and the world is still filled with all of these planes moving around. And you're just like, well, where are people going? I thought we were on lockdown. I thought we couldn't go anywhere, right? Mm-hmm. And really what that demonstrates to me is that no matter what, we're going to figure out a way to waste energy, right? We're all
Mm.
supposed to be at home. We're all supposed to be locked down, like everybody around the world for the most part. So then why are all these planes still off the ground going places?
There
Right?
are some emergencies.
Yeah, so-called, right?
Mhm.
But I mean, for the most part, for me, it's just it was a demonstration to me about we're not willing to really give up our convenience of being able to do what we want to do when we want to do it, right? Even if that means we're going to be destroying the earth in the process. So it's really about the education of getting us all to understand in general that we're in this together and we're all trying to like save the earth for everybody. And I think we have to really start to make those sacrifices whenever we can.
So,
But
so what do you think should go first?
So I think our priority really should be on making that shift happen. So we have to really think about reframing the world. So again, first and foremost, job creation, right? We need to start creating jobs and training people to do those jobs and getting people excited about those jobs and interested. We have to stop supporting things that waste energy. Like, it's not a way to shame anybody, but like we have a really big dependence on cars. We don't need to have a dependence on cars, especially if we have major cities, right? We have public transportation. We should invest more in public transportation and make public transportation actually work, right?
Okay, so as far as public transportation, aren't buses bad for the
So,
earth?
a bus looks like a bad idea because of all the fumes that are coming off of a bus. But if a bus is carrying 40 people versus 40 people in individual cars,
Okay.
we want people we want 40 people on that bus.
Okay.
Right? Yeah. So that's kind of the difference. And also, like, public transportation doesn't work all the times right now, especially like look at DC. Our public transportation is terrible, right? We have a vast system that does not do what it's supposed to do. Our buses are actually pretty good. I got to say, our buses in general, they are generally pretty good. But our metro system, why is it always failing? Why is it there are always problems with it, right? And so we need to just do better and invest more in that. But instead, we invest in roads and fixing roads so people get more cars. And I think in like a city like DC that has so many people coming in and out of it from around the area, we make a big statement if we're just like, okay, in this city or in this certain part of the city, you can't drive at all. It's only pedestrians. And so the only way you can get back and forth is hopping on the metro or taking a bus or whatever. But like, you can't come in here. You can't drive your personal car here. I think that would make a big statement to people about what's important. So things like that, I think, is where we should start personally.
Jesus. I'm not trying to give up my car just yet. Maybe after I get a little bit more research in this.
Or go electric.
Because they be tripping on that bus. Them crazy people. I don't got time to sit next to them. I don't got time. I'd like to be in my own personal space. But yeah, we're gonna do some more research.
So the thing about buses and crazy people, has anybody ever been on a bus without a crazy person?
Yes, with a crazy person. Yeah,
without a crazy person.
Without. No, not in DC.
Okay,
I don't even know if that's such a thing.
Good, because if you can't identify the crazy person on the bus, the crazy person is you.
Oh my God. And you know what? And they would never know because I'm quiet and I'm not up talking to myself and doing nothing crazy.
Publicly, so they be all right.
Yeah. They won't be having me on camera.
All right, so let's look at this periodic table of elements. Have you guys heard of the periodic table before? Yes?
Yes.
Okay. So the periodic table is just an organized way for us to look at all the elements of the world. So we're going to go through that a little quickly, and we're going to talk about what a periodic table is. First thing, though, is what is an atom? What's an atom? Anybody know?
If you ask me, I'll say it's a bomb.
Okay. We do have something called the atom bomb or the atomic bomb.
The weight of something?
It's a what?
Is it the weight of something?
The weight of something. So an atom is what actually we think is the smallest particle, right? So everything is made up of atoms, right? Even though atoms have different parts, everything, every person, every table everything that exists is made up of atoms, all right? So when we think about an atom, it is the smallest particle, okay?
Oh.
Okay, so that is, even though there are parts to an atom, we still think of it as the smallest particle. And the reason we think of it as the smallest particle is because in order to separate the pieces of an atom, we have an explosion, which is how we create the atomic bomb. The atomic bomb is the result of us trying to engineer or take apart an atom. So once an atom is formed, we can't take it apart without a nuclear process, which creates a bomb. So the atom is the smallest particle. That's what an atom is, the smallest particle. The smallest thing we can have is an atom. And an atom has parts. So the atom is made up of different parts. Does anybody know what's inside of an atom?
I don't know.
Proton.
Okay, sorry.
Okay, so smallest particle and it's made up of different parts.
Yes, so it's the smallest particle because you cannot separate it. You as a person, like we as people can't really separate an atom without making a nuclear explosion. So that's why we call it the smallest particle, because when we try to separate it, things explode. So it's the smallest thing that we can have, because anything we try to make smaller gets destroyed, right? So the smallest thing we can actually have is an atom, but there are parts to an atom. So the things on the outside of the atom that rotate around it. So these things, these lines are actually just showing movement, okay? So these little balls that hang out around the outside of the atom. And again, this is just a drawing to make it look like a real thing, but it's so microscopic and so small, we can't actually see a lot of this happening, just so you know. But the things that rotate around an atom, okay, and that give it a charge are known as electrons. Okay, so electrons rotate around the outside of the atom. And there are different layers of electrons, and depending on how big the atom is, right, because an atom can be big or small, it has many different layers of electrons in different numbers. And then in the middle of the atom, which is called the nucleus, now you can see where the word nuclear comes from, because we've called the center of the atom the nucleus. So this is how we get nuclear when we're talking about things that require atoms and the breaking apart of them. We call the nucleus. In the nucleus, we have two different colored things, right? These two different colored things represent what are known as protons and neutrons. All right, do any of these words look familiar?
Yeah, it's a word that we see. I mean, like I come across sometimes, but you don't know their meaning. So.
Yep, okay. So we have electrons, and electrons have a negative charge. Protons have a positive charge. And what kind of charge do neutrons have? Any idea?
I
If
think it's
they're
neutral.
I mean, they're
What?
nude. Maybe they're. No.
So they don't have any charge. They're neutral.
They're nude. That's what I wanted to say. Neutral.
Okay, they're neutral. There's no charge, right? So they're neutral. Just like when you have that N on your car, those of you who own cars, and you see that N in between the R and the D, right? Does your car go forward or go backward when you put it in N?
No.
Right, it doesn't move,
That's
it's
the direction
neutral.
forward, 'cause if you want to heal, it's gonna go back.
Right, exactly, right? It just depends on where it's positioned. Exactly, that's the same idea with a neutron. A neutron is just there to give it that extra weight when needed, or it doesn't do anything if it's in balance. Okay, so that's a neutron.
Oh, okay. And protons is positive, right?
Protons are positive and electrons are negative. Yep. All right. So an atom normally doesn't have any charge because electrons and protons are in balance. When they're not in balance is when an atom has a charge, okay? And we don't really have to really deal with charges that much when we're thinking about the kind of science that we're doing. But if you do a chemistry class and you work more with chemistry, you'll know that charges are important when we're trying to pair things up. And so you always, if you have a negative atom, you want to pair it with a positive atom, right? And they're always going to seek each other out, okay? All right, so an atom when we're thinking about an element, right? An element is made up of an atom of something, right? So atoms get their names based on what kind of element they are. So every single element we're about to discuss is an atom, but its name changes depending on what kind of atom it is because it has a different makeup of neutrons and protons. And then that's why it gets its name as an element, all right? So they all are the same basically, right? Hydrogen is going to be the same as boron or carbon, but because they have different numbers of neutron and protons, and you guys don't have to like know this right now, just like giving you kind of a preview, and we're going to get really deep into it in a second. When they have different numbers, that's what actually gives it the name of carbon versus hydrogen, right? When I get more neutrons and protons, I become a different atom, okay? And every atom has been labeled a different element. So this is what we have here in our periodic table of elements, okay? Let me clear this drawing. This is our periodic table, okay? Our periodic table is made up of all of the elements we have discovered so far, okay? And they're in order, basically from 1 to 100 and something, I always forget the number, based on the number of protons that they have inside of them, okay? So hydrogen is the first one,
So
and
you
it has,
said up to 100?
it's like 121, something like that.
All of those ain't gonna be on the test, are
Every single one, no.
they?
No. So just the idea of the table is on there and how you read it. Okay. So we're gonna show you a cheat sheet in a second on how to read the periodic table, and that's the only thing you're ever going to be tested on about the table. You do not have to know all the elements that are on the table. If you want to memorize them, that's great. I remember in my 10th grade chemistry class in high school, my teacher made us memorize them, and she quizzed us on them, and it was terrible, right? Because I did not remember them, and I felt really bad about it.
Fast forward, look at your name.
Right? But it is not something that you're ever going to need to know, okay? It's important to know them generally. And then again, if you take a chemistry class sometime further down the line, then you will need to know more about it, but you do not need to memorize all of them by any means, okay?
Mm.
All right.
I don't think at this
Yeah.
point of time I can memorize anything anymore.
That's
gone.
You have the ability.
Do you need to know these elements to take the test, the GED test?
So you need to know how to read the table. And I'm going to show you what I mean when I say read the table, but you do not need to know all of the elements. You need to know how to read the table. So I'm going to show you what that means right now. I think this is the next slide. Let's see. Let me skip ahead. So I'll show you exactly what it is. This is what you need to know, how to read the table, okay? This is how you read the table. This is what the information that you need to know. So let me stop sharing for a second, actually, because I want to make sure that you guys have the document that you need. It's in your Schoology page under week 3. It should say periodic table notes. I'll share where that is for you. So the periodic table notes, right? This last file here in your week 3 folder, if you open that up, it's going to look like this. Okay. All right. And this is where you want to take notes today on what I'm about to show you on this PowerPoint slide. So this is what you need to take away from today, because this is the information that you're going to be tested on the GED exam. Okay. How to read the table in this way. You do not need to know every single element that's on that table. You just need to know when they show you this snapshot of an element that looks like this, you have to identify these numbers and these names, okay? That's what you have to know, all right?
Just that right there.
Just this right here, yep. What
Can
about,
you leave that right there for a minute real quick? Just that middle box?
sure.
All right, you can take it off.
No problem. Thank you. All right. So if we take a look back at the notes, open this back up. Sorry. Back to our PowerPoint. Let me go back to the slide. I think it's slide 7 or so. Let's see. Loading, loading. Got one more. All right. Okay, so this is what we need to know about our periodic table. We need to know that this top number in every box represents the atomic number. Okay? So the top number in every box is the atomic number. The letter or letters in the middle represent the element symbol. Under that, we have the element name. And at the bottom, we have the atomic mass. Okay? What does the atomic number tell us? The atomic number is important because it tells us two things. The atomic number tells us the number of...
I'm sorry, Mr. Graziano. I think we all was writing it down, trying to write what's on the screen. I'm sorry, what was the question?
Oh, no, it wasn't. I was just asking it generically. I'm going to tell you what the answer is.
Okay.
All right. So the atomic number. The atomic number tells you the number of protons in the element. Okay? That top number, the atomic number, always tells you the number of protons in the element. Okay? The number of protons is always equal to the number of electrons. And the reason that is, I told you guys that reason before, is because we want to make sure that there's no charge on our element, right? So the number of positive charges has to equal the number of negative charges. So that atomic number always tells us the number of protons. So as the number of protons change in my atom, I become a different element. Okay, so if I go from 6 to 7, I'm no longer carbon. I'm a whole new element. Okay, and whatever number 7 is. So that's why that number is important. Okay, but the atomic number tells you the number of protons. This is always equal to the number of electrons. All right, what about the atomic mass? The atomic mass is the number of protons plus the number of neutrons. In this case, right, this total is 12. It's a little bit over 12, but it's 12, right? If we know that the number of protons is 6 and my atomic mass is 12, how many neutrons do I have?
6.1. Oh.
Yeah, 6. We're going to round it to 6.
So, yeah, 6.
In this element, it's not going to be the same for every element, right? But in this element, I have 6 protons, 6 neutrons,
And 6 electrons.
and 6 electrons. Okay?
Mm.
So that is the information you need to be able to garner from the periodic table. So if they flash you a slide that looks like this, and it has a chemical, right, an element, and it has the symbol, the name, everything, they might ask you any of these questions. What are the number of protons in this element? And you should be able to read it and say, oh, well, that top number tells me that I have 6 protons, right? What are the number of neutrons? Well, this bottom number minus the top number is going to give me the number of neutrons. Okay, so that's what you need to be able to read from the paper.
Oh, okay. So you subtract the 12 from the 6, okay?
Yep. Okay. That's the kind of information you guys need, and not, not the name of every single element in the table. Okay, you just need to know how to read the box for every element. Does that make more sense?
Mm-hmm. Yeah.
I see some of you writing furiously. I do want to remind you there is a notes page that I've included in your folder.
Right.
But the notes already on it?
You have to write the notes in, but all the blanks are there for you.
Oh. It's good. Confusing, man. Going back and forth.
Oh yeah, I know on the computer. Yeah, it is confusing to go back and forth. It's true. We'll be back in person one day. One day.
And I think there's even advantage on it as well. I like it somehow, but then using at least it's making you get used to the laptop, and so
Yeah.
to it will be better for when you have a job and
No
having
belief.
anything to do with laptops.
Yeah. Yeah, I think the difficulties are not being able to balance everything, right? Like having to have a note sheet and a computer, going back and forth between the different things you need on the screen. Those are the challenges. But I think there's a lot to be said, especially for me, about just being in the comfort of my own home. Like, I like the fact that like I get to wake up later, get ready and then start teaching versus like I have an hour-long commute to work, I have to get ready earlier, these things, but this is good. All right, is everybody good on the notes? Okay,
Yes.
perfect. All right. Again, I'm gonna switch my share to the notes page. I want you guys to see that. Okay, so this is the notes page that I've included, right? So what is this top number again?
It's the atomic number.
Good, it's the atomic number. And what does the atomic number tell us?
The number of protons are
Okay. Yep.
Always equal to electrons.
Okay, good. So this is my atomic number and it tells me my number of protons, right?
Mm-hmm.
So how many protons do I have in this element?
28.
28, good. How many electrons do I have in this element?
28, right?
Yeah. Good question. Yes, good. All right, what is this Ni here in the middle? What is that?
That's the element symbol.
Good. The element symbol, also known as the chemical symbol, either one. Either word is perfect. So we call it sometimes the chemical symbol, sometimes it's called the element symbol. Both words work. Okay. And what is nickel?
The element's name.
Good. And what is the number at the bottom here?
Atom mass.
Yeah.
Okay. So, yep, atomic mass or mass number. Again, these are interchangeable words and you will see both. Okay, so don't be confused. If I see the word mass, I'm talking about the number at the bottom, right? Either it's called atomic mass or mass number. Both of those terms are used, okay? All right, and what does the mass number tell me?
You said okay, minus 28.
What does it tell me? What is it in general? What is the
It
mass?
tells you to
Okay.
number of protons plus number of neutrons.
Mm.
Okay, good. Yeah. So it's the number. The mass number tells me the number of protons plus neutrons. Good. Okay. So in this element that we see on the screen, how many neutrons do I have?
Okay, so this element.
30 something.
We can call this 58.7 if that helps.
Mm-hmm.
So how many neutrons do I have?
I think it's 30.7.
Perfect.
So do we round it off? I was about to say, do we just leave it at 30?
Because so I would say 30.7 or I would say 31. If we're gonna round correctly.
Yeah.
Right?
Oh,
Round
yeah.
up.
Okay.
Okay.
Okay, round correct. So we're gonna have to round up to 31. Okay, so that
Mhm.
also works. All right, yes. You guys didn't know you were doing math this morning, did you? You're like, oh, I have science class. I don't gotta
Mhm.
I know science is filled with maths. Maths.
caught you off guard. So yes, I take my 58.7, I subtract 28. I'm gonna end with 30.7, which is fine as an answer. But if you're doing a multiple choice and you don't see 30.7, you should be looking for 31, okay? All right, so that is the number of neutrons that I have. I have 31 neutrons in this element.
I feel good about it.
Good. All right. And basically that is just a little bit of some of the math you might have to do on the GED exam. The other math will be dealing with formulas, and we'll get into that a little bit later, not today, but later into the term. But this is what you need to know about your periodic table. How to read this box here, which includes the atomic number and the atomic mass, and then how to do the math of the periodic table, which is finding the number of protons, the number of electrons, and the number of neutrons. All right, so do you guys feel comfortable doing that? Do you think you could do that on the test?
We will try.
You'll try? I have faith in you. I have faith that you guys can do this because this is a pretty straightforward thing, okay? Once you know it, you might have to review it again, but I think it's a pretty straightforward thing. It's one of the few things that you have to know before you take the science test, okay? So the science test is really based on your ability to read a passage and apply scientific knowledge. This is one of the few things where you actually have to know how to do this before you take the test, right? There's only like 5 things on the GED test that you have to know going in. This is one. The other one is how to do a formula, how to use a Punnett square, how to balance a chemical equation, and, oh wait, might be only those 4 things. Yeah, only 4, not 5. But you guys have knocked out one of the important ones. Okay. Okay. All right. Let's stop this share for a second. I'm gonna do something else with you all. Okay. Week 3. Let's unpublish this. And let's publish that. Okay. So let's talk about what you guys are doing for the rest of today. And I'm actually not going to keep you all till 12:30 today. We're going to do this and we will be good. Okay. So here is your week 3 folder, right? You guys have already commented on the discussion. There's a handout here of the periodic table, just in case you need a copy of what the periodic table looks like. It's there just for your reference. You have the PowerPoint on the periodic table if you need to review anything. It has all the information that I actually just went over very quickly with you all and did the notes. If you guys look towards the back of it, it tells you a little bit more about each of these steps, why they're important. You guys can go through that if you need to. Again, we already did the most important thing, right? Make sure you do fill out your own notes on that PDF that I just showed you with the nickel. Fill it out yourself so you have it. And what I would like you guys to do on your own is watch this video about coal. So if you click here, it'll come up. It's a video, but you have to put in this password to access it. It's about 14 minutes long. So I would, just watch this video and then answer these questions. I think it's a really good way for you guys to engage a little bit more with the idea of climate change and why coal is important in this country. So whenever you get a chance to just go ahead, please do that. And then next week, we'll do a practice activity with making sure you guys know how to do this periodic table math. We'll do a little practice on that. And then we will get into some new stuff next week. All right, are there questions I can answer before I release you all into the world and into your weekend? No? Everything's good?
Nope, I'm good.
All right, well then enjoy, and I will hopefully see you all next Friday if I don't see you for math. All right?
Oh, okay.
Hold on, question.
Thank you, and you too have a great weekend.
Yep, no problem. Yes, Jeff.
So do we have to learn hydrogen 1 and lithium, or just stick to neutron and proton?
Yeah, all you need, you do not need to know the number for each element. No, that is not important.
Okay.
Just hydrogen when it's presented to you. Absolutely. Yep. Good
Thank you so much, sir. Have a good one.
You too.
Thank you. Bye-bye, everybody. Have a wonderful weekend.
You too. Bye-bye.
Thank you.